going to show you some results from a work that I've done at Durham University in the past months, because I was working in Durham until March. And these are work has been done under the umbrella of an ERC project, class project, which is the director of the project is Dana Lawrence at Durham University. It's an ongoing project which started in 2019. So in okay. So what we have done in this work is to see how population dynamics change across the world Near East, and to what degree they were affected by climate change. So in order to answer our research questions, we use a different kind of proxies. We use the archaeological settlement data, radiocarbon dates for modeling population dynamics. And then we used 16 paleoclimatic records as a stable oxygen isotope from speleothems and lake sediments. So the SPD, summer probability distribution that we model by using our radiocarbon dates, are shown in these slides. So in gray we have SPD created by using all the dates, and in green just the SPD using just the radiocarbon dates from short-lived samples, because we wanted to see if maybe there is an old wood effect that is if we use all dates. And as you can see, that both distributions are quite similar. In fact, they show they have a Pearson correlation, which is R equals 0.95, so it's really high. And then we compare our observed SPD against two null models, one logistic and one exponential, in order to see and to highlight periods where population was increasing more or less than expected according to the null model. So in red shaded area, you have population increasing more than expected. In the blue shaded area, population decreasing more than expected. So the general picture that we have by using all dates from all regions, from the wall of Near East, is an increase of population already in the late Pleistocene. Then population is increasing during the early Holocene, then it's quite stationary during the middle Holocene, and then it's peaking in the later periods, so from the second half of the middle Holocene, so with the early Bronze Age and the Iron Age, so from 5,500 BP, 3,500 BC. And what we have done then is to see how population dynamics varied locally. So we used the permutation test, and for each region, because then we subdivided the whole Middle East into seven major geocultural regions. So we compared how the population dynamics from each region departed from a pan-regional trends. So the gray envelope represents the permuted pan-regional trends, and then we have the observed SPD. So you can see different variation. I will highlight just one today, given we don't have so much time. So for instance, if you have a look here in the Levant and Mesopotamia, population is already increasing in the late Pleistocene, so during the Younger Dryas. Instead, in the other regions, we don't have this increase. And this is due to the fact that during the Younger Dryas, so this is a map published in the article by Neil Roberts and colleagues in the Quaternary Science Reviews. So, and it shows you areas in yellow, the areas where cereal growth is possible. And during the Younger Dryas, despite in the other regions there is a restrictions and it's impossible to grow cereal, in the Fertile Crescent, climatic conditions are still good, so are still favorable. So likely the Fertile Crescent acted as a sort of refugia for plant species and humans. So in that area was possible a full domestication of plants, because the domestication of plants in the Near East started already 3,000 years before the onset of the Holocene, and also the Neolithic. It's already started in, according to Dorian Faller, at around 14,500 pp. So this would explain, so different climatic conditions would explain also different and localized population dynamics in the Fertile Crescent, so in Upper Mesopotamia and the Levant. And then we have compared our proxies that are hydroclimatic proxies. And by comparing all of them, the scenario is that the climate is getting warmer and wetter since the onset of the early Holocene. Then we have wet and humid conditions until 7,000 BP. From 7,000 BP, we have a shift towards more arid conditions. And then in the late Holocene, but already from the 5,500 BP, we have a drying phase, as you can see from all proxies. And then we can see here the 4.2 and 3.2 K events. So where we have a drying phase in the Near East, and it's quite ubiquitous here in all proxies. So what we have done then is comparing the SPD of each region against their local paleoclimatic proxies, and we have done this for all regions. So I picked up just one example. So this is the Levant. And you can see that population, again, is increasing already in the Pre-Paleolithic, then in the Pottery Neolithic, when also you have humid condition is increasing, then it decreases during the Middle Holocene, and it peaks again when we have a more complex societies. And what we have done also, for those paleoclimatic proxies where we have a good resolution, we have calculated a 500 moving window. So if population and climate are correlated within a 500 years windows. So in this graph, in red, the dots represents periods where we have strong and significant positive or negative correlations between paleoclimatic and archaeodemographic proxies. And for instance, here, this represents that in this within 500 years, the population and climate are highly correlated. Instead, here, there is a negative correlation. So despite a drying phase, population is booming in the early Bronze Age. But then again, we can see here the impact of the 4.2K event on the local population, because when population is dropping as a consequence of an aridification. And so the general patterns that we have detected in this study is we can see a correlation between paleoclimatic and demographic and proxies on shorter periods. And there is a lot of regional variations. So that we can detect some pan-regional trends, but there are more localized response. And with the onset of the Holocene, we can see an increase of population, and most likely weather conditions favor the increase of population, and also the endemic spread of farming across the Middle East. The rapid climatic changes affected in different ways the population dynamics in the Near East. And what is interesting is that since the second half of the Middle Holocene, we can see a decoupling between paleoclimatic and demographic trends, and roughly from 5,500 BP. And yeah, that's it. Thank you for your attention.
Yeah, I have a question, Alessio.
Yeah.
So you mentioned the possibility that the Fertile Crescent may have been suitable for agriculture during the Younger Dryas. Is there any evidence for agriculture during the Younger Dryas in that area? Any physical evidence, any archaeological evidence?
Sorry,
So I was just asking. I was just wondering it really is surprising to think that you could have agriculture, even several thousand years back before the supposed date of agriculture began in that region. Is there any evidence for that?
Yeah, there is a study by Dorian Faller, but also Sioux College, that domestication started already in the Near East at around 14,500 BP. And
I didn't know that.
And the argument is that because in the Levant and in Upper Mesopotamia, the Younger Dryas doesn't affect those areas. Likely in the Levant, there was the spread of farming because you have 3,000 continuity of domestication, something that in the other regions in the Near East you don't have. So this is the argument that despite the Younger Dryas in the Levant and in Upper Mesopotamia, the climatic condition was still favorable.
Amazing.
Any other questions? I have a question. This decoupling of climate and population trends from, oh, sorry. Did someone else have a question?
Yeah.
I have a question. But...
No, go ahead, please. Whoever, I'm the moderator, so please ask your question.
Just a general question for what the logic of using, first, what is the logic for using a exponential of a logistic population growth as a null model for a time span of 10,000 years? What is the logic of using a short-term population models, which is for generation times of hundreds of generation times for humans, in a time scale of 10,000 years, like a null model? I think there is a problem here from population dynamic theory using this scale of time. And the same question for the relationship between climate and population dynamics. Why do not trying to looking for first the right scale of time to link population dynamic process with climatic changes?
So on a shorter period?
Yes. First, trying to looking for the signature of demography and climate first. You trying to, and then section or slicing the time series, looking for the coupling or the decoupling between climate and population dynamics. If you are looking for the all-time series or a long period, it's very difficult, maybe, because the nature of the changes in human populations.
No, that makes sense. In fact, I mean, we use the 500 years moving window analysis because we wanted to detect the correlation shorter periods. Unfortunately, most of the mean sampling interval of these paleoclimatic records is like 250 years for the Near East. The resolution is not good. So for one paleoclimatic proxies, the Jeta cave, you can do this because you have a better resolution. We use 500 years, but for the other ones, it's very difficult. But it makes sense what you say, because when you look at the longer scale, long period, the correlation, of course, they are low because you are looking at a very long time span. And here, for instance, as you say, when you have a drop of population, and it's not necessarily related to the 4.K events, could be also because they exceeded the carrying capacity. There were some settlements that grew rapidly in the Near East, And then because they exceeded the carrying capacity, then you have a drop of population. So maybe the climatic event triggered this decrease of population. So yeah, no, I agree. It's much better to have a look at a shorter scale. In some cases, it's possible. In other cases, we can come out with this rough figure. But yeah, I agree with what you said.
Okay, thank you.